Hello. I want to give you a little crash course with the filled-in notes on Chapter 12, which is exploring 3D solids. Now, the thing with 3D solids that we need to keep in mind, we need to be able to classify them, and we also need to be able to compute their surface areas and their volumes. And the good news is, if you are able to understand the formulas very well, this shouldn't be too bad for you. So the basic vocab words are up here. So a polyhedron is a solid that is bounded by faces, 2D shapes that enclose a single region of space. And the edge is the intersection between the two faces, and then there's what's called the vertex, where three or more edges meet together. We can name the different types of 3D shapes. Not every 3D shape is a polyhedron. So they have to be, flat surfaces, faces, and they can't be like round. So cylinders and cones are not polyhedra. However, prisms, cubes, and pyramids are. So here are some basic types of shapes. So we're going to be able to compute different types of surface areas. And the idea of a surface area is that you are going to be taking a 3D shape. You're going to compute the areas of all of the faces, and you're going to add them up. And there's a shortcut. So for these prisms and cylinders, if you take the area of a base, so you're able to find a base, so in this case it's a square, triangle, circle, and you multiply it by 2 because there's a top and a bottom, and then you do the perimeter of the base times the height of your prism or cylinder, then you're going to be able to find the surface area. So let's look at an example here. So I have this right prism, for instance. So I find the area of a base, which is 7 times 7, which is 49. I can also find a perimeter. So the perimeter of my base is 7 plus 7 plus 7 plus 7, or 4 times 7, which is 28 yards. And then I go write down my formula, 2 base times plus perimeter times height. So I'm going to do 2 times 49 plus 28 times 5 equals 238 square yards. I can have a little fun, like on this example, and actually we could use our 11.2 for the pentagonal prism, and we could actually find the area of the pentagon using the area formula from section 11.2. So the apothem is 8.9, so I have 1/2 times 8.9 times 13 because that's my side length, times 5 because I have 5 of those equilateral triangles. So the total area of my base is 289.25, and then my perimeter is 13 times 5 because I have 5 sides, so that would be 65, and then I could just use my formula. Then I have a special case, which is a cylinder, where the area of my circle is pi r squared, and then the middle part of my cylinder, so the part that's not the top and the bottom, I do perimeter, which is 2 pi r, which is circumference, times height. And then I can plug in, I got my radius, which is 4, and I got my height, which is 7. So I'm just going to plug it in. So I'm going to find the area of my base, 8 pi. And then I'm going to add to that, I got 7 times 8 pi. So I got 32 pi plus 56 pi to get me 88 pi square units. You may be asking what happens if I don't have a radius and I have the diameter instead. What you can do is you can just divide 14 by 2 to get 7. And then I can just use my formula. So I find the base, 49 pi, and then I do 2 times 7 times pi, which is 14 pi. So I got 2 base times circumference times height, and I just plug in the necessary ingredients. For pyramids and cones, we have something that's called slant height, and that's a cursive L. So that would be base plus 1/2 times perimeter of a base times the slant height. So if you are given the slant height, that's going to be your cursive L. And let's say I have this regular pyramid. I compute the area of my base, which is 4 squared, which is 16. My perimeter is also 16 because I'm just adding 4 each time. And I have 16 plus 1/2 times 16 times 6.3, which is my slant height. And I get 66.4. And you can round to 1 or 2 decimal places as long as you have those square units. And with the pyramid, it's the same idea, except that my base, instead of being a square, is going to be a triangle. So I'm going to do 1/2 times 9 times 7.8. And then my slant height is 11.3. And I do the same type of plugging into the formula. So base plus 1/2 times the perimeter of a base times slant height. So it's always good to start by thinking about one piece at a time. Area of a base, find a perimeter, find a slant height. So that way you find all the variables that you need to plug into the formula. Now what if you have a cone? What you can do with the cone, it's pi r squared times pi r times the slant height. And the slant height of a cone is just basically like if you just imagine the edge of an ice cream cone. So 30 would be the slant height here, 23.4 would be the slant height here. So I have in this one pi times 13 squared, 13 is my radius. So I have pi times 13 times 30. And I could just add those up to get 559 pi. And truthfully, I would take that as the final answer, but if you want to multiply it out and multiply by 3.4, that is okay too. Also, in 3D, we take volumes. So you can think of a prism or cylinder as the area of a base times the height. Or, let's say we have a cube, you could say like length times width times height. Length times width is the area of the base, but we can think of it as just area of the base times height. And in a cylinder, we can customize it and put pi r squared as the area of a base. And then the volume of a pyramid or cone is 1/3 times base times height. And with the area of a base being of a cone, being round, 1/3 times pi r squared. And I think it's really helpful. Sometimes the shapes are not going to be right side up. Shade in your base, compute the area first, and then just multiply by how far outward you go, so that 4, to be able to capture that true volume. Let's say we want to do this hexagonal prism, so maybe that's not an explicit formula, so you have to find the area of a base first. So it works very well. So I know how to find the area of a base from 11.2, so I do 1/2 times 6, which is the apothem, times 4 square root of 3 times 6, apothem. I multiply the 6 of those triangles together, and I get 72 times square root of 3, and you can keep it like that, and then I just multiply by 12. And then here are a few more examples too. This one involves slant height, so we're going to do the 1/3 times base times height, and height being, and we can find that based off of a slant height. So 3, 4, 5. And we can plug that in. We get 48 units. So good luck with the Chapter 12 crash course. I have a few worksheets with the formulas on there for you. And they have a slightly different approach, but feel free to experiment with both approaches. All what I care about is that you can compute both the surface area and the volume. So thank you very much, and happy studying.